Alright, so on this video we're going to be talking about end behavior, which is one of your characteristics for functions. And while you're only responsible for linear and exponential functions this year, if you can get this idea down, it works for any type of function. And so as you progress through high school and further on, if you go further on in math, these same concepts are going to apply. So any function we can do this with. And I want to show you a few crazy ones just to point that out and prove the point. So for end behavior, you're basically looking at what's happening at the ends of the functions, keyword being end here. It's called end behavior, so you don't care about what the function does in between, like in the middle of it. Alright, you're caring about what happens toward the end, toward the arrows. And my hint to you is going to be look at the arrows because that's where the ends are. So even though the arrows technically mean we go on forever, that's our theoretical ends that we're looking at, so we got to look those directions. So first things first. You're going to need to either use Freddy the function writer or don't. But remember in class we talked about, imagine you had a little man that starts in the middle and he hops on functions left and right this way. So for end behavior, and I'm going to show you the setup in a minute, but remember we take him to the left and we have to see what's happening to the function as we go to the left. Maybe it's pointing up, maybe it's pointing down. And then we have to take him to the right and see what's happening. So for this type of characteristic, we're going to make him start in the middle and we're going to take him to the left, which is toward negative infinity, x values. And then we're going to take him toward the right, which is toward the positive infinities for the x values. So to prove that, here's your setup. So we're going to take him to negative infinity, which is the left. And then we're going to take him to positive infinity x values, which is the right. And this is how you're going to set all of these up. You're going to try to fill in these blanks over here. You need to know what y is doing, or what your arrows basically are pointing at when you go to the left and when you go to the right. So for instance, on this one, you've got to figure out what's happening at the ends of your function. Well, the ends, again, you need to look at your arrows. So for this one, imagine Freddy standing in the middle. We're going to take him toward negative infinity. And we're going to take him toward positive infinity, x value-wise, and we need to see where these arrows are pointing. So you format it the same way. As x approaches negative infinity, we need y to approach something. And as x approaches positive infinity, we need y to approach something else. And basically it's a fill-in-the-blank problem from here. So as we walk Freddy to the left on this function, where's the arrow pointing? Well, here's the arrow. It's going to keep going y value-wise down toward negative infinity down here. So y is approaching negative infinity. Alright, if we take him to the right this way, the arrow on this side is pointing up, and that means we're heading toward positive infinity. So we're going to say y approaches positive infinity. So as we go to the right, we're going up, which is positive infinity, forever. As we go to the left, we're going down toward negative infinity, forever. Alright, another example. We're looking at the ends again, different line. But you still got Freddy, and we still got to take him left, and we still got to take him right and see what's happening at our arrows, at our ends. So we're going to say as x approaches negative infinity, y approaches something. As x approaches positive infinity, y approaches something else. So again, take him to the left. Look at where that left arrow is pointing. It's pointing up toward positive infinity, so that means our y values are going to positive infinity. As we take him to the right, here's our right arrow. He's pointing down toward negative infinity y values. So we're going to say y is going to negative infinity. So opposite of last time. Alright, different function, the one that you are otherwise responsible for, the exponential function, still has arrows on it, so we're still going to talk about what happens at these ends. And still have Freddy, but let's set it up. As x approaches negative infinity, y is going to approach something. As x approaches positive infinity, y is going to approach something else. So again, Freddy's standing in the middle, base camp. He's going to walk to the left. Well, this time, this arrow is not pointing all the way down to negative infinity. We talked about for exponential functions, there's this imaginary line that this function approaches, and I'm trying to highlight that for you in green. It's hard to see. But there's this line here that this function's getting close to but never touches, and remember this line is called your asymptote. And our asymptote for this one is at y equals 0. It's a horizontal line at the axis here. So this arrow, even though it looks like it eventually may touch, it's just going to keep getting closer and closer to this x-axis line. And that's our boundary line. So this time we can't approach. This arrow is not pointing toward negative infinity. It's got to point where we're approaching, which is 0. So we're approaching 0 on the left when we walk Freddy to the left toward negative infinity. But on the right, if you notice, this arrow is definitely still pointing up toward positive infinity. So we're still approaching positive infinity here. Alright, so basically your asymptote has something to do with your end behavior because it's going to make a boundary that you can't go past. So the negative infinity is not an option here for this one. Alright, likewise on this one we got arrows still, but this is an exponential, so we have an asymptote. And if you notice this time, and my drawing's not perfect, but I made it to where my asymptote is at y equals 1. So we're not at 0 anymore. We're approaching 1. So if I go write my end behavior, I got to figure out again what's happening. Well, as I move Freddy from the middle to the left, that arrow is pointing up toward positive infinity. So this time, he's shooting up to positive infinity y values. But as I take him to the right this time, that's the arrow that we're going to need to be concerned about as far as the asymptote goes. So that arrow is not going to ever go past that asymptote. It can't ever get to negative infinity y values. So we got to go to where it's approaching, which is 1. So y values are approaching 1 on the right-hand side as we go toward positive infinity x values. Alright, and just to prove a point, like I said, this works for any functions. This is a crazy, crazy function here. It crosses several times on the axis. You're never going to learn about this early on in high school, but just to prove a point, what we care about is the arrows. Remember, it's not called middle behavior, so I could really care less what's happening in here. So don't even look there. So our end behavior, though, as x approaches negative infinity, y needs to approach something. As x approaches positive infinity, y approaches something else. Well, as we walk Freddy to the left, this arrow is pointing up to positive infinity, so this one's going to positive infinity. As we walk him to the right, this arrow is pointing down to negative infinity. So I don't care what's going on in the middle of this function. You can scratch it out, whatever. We care about the ends, which is these arrows that I circled. Alright, so you try this for a minute. Pause the video, see if you can write these 4. I didn't give you an exponential just because I didn't have a grid, but go back and look at those 2 exponentials if you need more practice on those, or come see me. Alright, and here's your answers. So again, all we care about is really these arrows. So this one's pointing to positive infinity, this one's pointing to negative. So on the left we're going to positive, on the right we're going to negative infinity. These both are pointing positive, so they're both going to be positive, positive, the y values. These both are negative, so they're both pointing toward negative and negative. And then again, this one's pointing toward negative infinity, this one's pointing toward positive infinity. Alright, so until next time, keep practicing this. Come see me if you need help.